look at the languages and automata part of lesson 3. You will find this theory in chapter 12.4 of Charm. Okay, first let's repeat what we've done last lesson. So you see a regular expression, R1, being A star B or B star A, and another regular expression, R2, being A star B. Okay, let's see what this means. So let's first look at the language generated with R1. Okay, what kind of words do we have? So apparently we need to start with an A, then we can choose as many A's as we like, including nothing, and we have to end with a B. So this is a correct word. We could also do A and then choose 3 A's and end with a B. Or we could do the second part. Then we start with a B, have as many B's as we like, including none, and end with an A. Or, for instance, we choose 4 B's and we have B5A. So all possible words. If we look at the set notation, that would be we start with an A, then we have as many A's as we like, we end with a B, or, and then remember, an or in set theory means that we have a union, or we start with a B, we have as many B's as we like, and we finish with an A. Okay, for the second one, we have first 3 A's. So let's look at a word. So that would be A, B. That would be a correct word. But you see there's a star there, so I don't even have to choose some A's. I can just put in B. Or I can do it twice. So I would have A, and then again A, ending with B. So the language generated with R2 would be 3 A's as often as we like, followed with minimum and exactly, not minimum, exactly 1 B. So these are the two languages we're looking at. Okay, if we look at a different situation, now we have a language given by a set definition. So apparently I can choose A or B as often as I like. So I can choose A and another time A, and then a B, and another time an A, but we have to end it with twice a B. So this would be a good word. Or I don't choose anything at all. I have 2 B's. Or I do 3 times an A and then finish off with a B with 2 B's. So in fact, it's all the words ending with 2 B's. If we look at the regular expression, so the corresponding regular expression would be we choose A or B as often as we like. This comma here means choose from A or B, and then we finish with 2 B's. Languages can also be described with the help of a graph. And you see an example of such a description on this slide. So if we look at the numbers we see at the vectors, at the arrows, then we see 0 and 1. That means that the alphabet we're using is containing 0 and 1. Then we see a big arrow here, and that means we have to start making words at this point. This is the entry point of the graph. Then we have a state. This S0 is called a state. So the initial state we enter in is S0. And then apparently we can take a 0 and stay in the same state. So if we start a word, we can take a 0 and we're still here. We can take another 0 and we're still here. But we can also take this arrow and go to S1 with the help of 1. If we are in S1, you see we only have the option 0, and we can choose as many zeros as we like. You notice that there is a double circle around the S1, and that means that this one, S1, is an end state. So the double arrow indicates the entry. These are states. And the arrows just tell us if we get a letter which is on top of the arrow, we have to move from one state to the other. If there's a circle there, it means we just stay in the state. So if we would describe this language with a regular expression, we would get 0 star. And you see you don't have to take 1 0 at all, because we can immediately go from S0 to S1 with a 1. To get to an end state, so a position where we can finalize the word, we need to have exactly 1 1, and then we can finish it off with a lot of zeros. If we would look at this in a set notation, it would give us 0, 1, and 0 star. Another example, so we have a starting point, this arrow, and we go in state S0, the initial state. Then we have to take an A. So the only way to get from this initial state to the end state, which is this one, we have to go with the help of an A to the next state. Then we can take as many B's as we like. So I don't have to take a B, but if I want, I can take 1 or 2 or more. Then to go to S2, I have to use an A again, and then I'm in S2. I can take as many B's as I like, and I have to finish with 1A. So the regular expression for this language would be A, B star, A, B star, A. If we would look at the set notation, it would be A, followed with B star, A, B star, and A. For simplicity, there are some agreements we do. So for instance, if we can go from one state, let's say this is state 1, to another state, and we can have either go there with an A or a B, then we could also use this same AB with a separator, and this means choose A or B. So compare this with the set description. So to go from S1 to S2, we can either take an A or take a B. If we have a proposition, a possibility to stay in the same state, so let's say this is state S3, and if I take an A, I stay there. And if I take a B, I stay there as well, etc. So this can be simplified by writing one arrow and saying, okay, if I have an A or a B or a C, I stay there. Then to look at this regular expression, we can describe a graph. So we have X or Y or Z. First thing first, you have to have an entry point. So whatever you do, we first start with an initial state. From this initial state, apparently, I can choose X or Y or Z. And I have to have minimum one of these. So I go to a next state with either an X or a Y or a Z. At this point, apparently I can end the word because the XI is containing with a star. That means I don't have to choose anything. So this S1 is a final state. If I like, I can end it here. So for instance, a good word would be X or Y or Z. But of course, we can also follow with a combination of X, Y. Okay, so apparently if I'm in this end state, then I can choose an X. We go to an X state. And I can go back again to the end state with a Y. So in fact, I've made a circle. So after I reach the end state, I can continue as often as I like with an X followed with an I. X followed with an Y. So now I get the words, for instance, starting with a Z, XY, XY, XY. Or x, and only once xy. So all of these possibilities are correct words in this language. So another one, we start at an entry point and we start in an initial state as 0. Then apparently, before I can move on, I have to take an A, a B, and a C. So I take an A, I go to a next state, I take a B, and I go to a next state. I take a C, I go to a next state. And as you see, what follows now is again with a star. So this S3 is my first possibility to end the word. And then of course I can take A or B as often as I like. So in this end state, I can take A or B, remember that's a comma separator, as often as I like. Okay, if lambda belongs to a language, what does that mean for a graph? Well, let's see. So we start. I have an initial state, and apparently I can finish immediately because I don't need to choose any letters. Okay, and the conclusion should be this initial state is also an ending state. If we look at this one here, so we have S0, we take an A, we go to S1, and we can go back again to S0 with either A or B. Now we see an entry point, an initial state which is also an ending state, so lambda is part of this language, and we see another state which is also a possibility. So I have several combinations. So what could I do? I could start with S0 and then immediately end. And so lambda is part of this language. I could also say, okay, let's take an A and then go back with an A or a B. And then I'm back in S0 again, and I could repeat this as often as I like. So if I start in the initial state, I can start with an A, go back with an A or B, and then go up again with an A, go back with an A or B, etc. Or we could start in S0 and end in S1. So what is also a possibility is to have an A and then end. And if we like, we can continue. So we can have an A, go back with an A or B, and then go up with an A again. And then this cycle could be repeated. And so we have several possibilities. We have to start in S0 and we can end in S0. And then in fact, we have this description. So starting in S0, ending in S0. And you see that this word lambda is part of this description because the complete one has a star. And the other option we have is start in S0 and end in S1. That is given with this description. So start in S0, so then we go to S1, and then we can continue by taking this cycle over and over again. So the complete regular expression would be A followed with A or B star, or A followed with A or B, A star.